Well, it is recording. So welcome to Math 230, 231 online for the summer. Our plan, like you saw on Canvas, is we're going to record these videos for YouTube. And if you're available at the times that we're doing that for, you can tune in like you guys are right now, those of you who are here. But for those of you who aren't and are seeing this on YouTube, that's fine too. So I guess today the general plan is just sort of introduce ourselves, get the feel of the course a little bit, take a look at Canvas and some of the other things, and then probably do the first lesson in chapter 12. But then tomorrow we'll go through a few more. Tomorrow will probably be a little bit longer lecture than usual since today we have this introductory stuff. But yeah, anyway, I'm Joe Roberts. I'm one of the instructors, and I guess, and this is Dom, the other instructor.
Hi, everybody.
Yeah. I guess, as you can see on Canvas, we're planning on having 5 videos per week, 2 lectures on Monday and Tuesday that'll be done by one of us, and then 2 recitations on Wednesday and Friday that'll be done by one of us. We'll sort of trade off week by week. And then we have a guided study group leader who's going to help out with a session on Thursday afternoon. The time for that might change. We'll keep everyone updated in Canvas. But yeah, so 5 of these sessions per week. You'll know the schedule. And feel free to tune in. Feel free to chirp in on the mic or in the chat. And yeah, I guess we can take a look at the Canvas page.
Just one quick question before we start.
Yeah, go ahead.
Will all the lectures be at this time at 3 o'clock?
Yeah, for the most part, we'll just try to keep a steady schedule. I think there's a total of about 140 people in this class, and people are all over the world, actually. That might be fun to post on Piazza or discussion board where you're taking this course from. It's pretty interesting, yeah. I think all of you are Penn State students for the most part, University Park predominantly. I could be wrong. But a lot of you are at home over the summer or working abroad, and it's pretty neat. So we just kind of picked 3 p.m. If you can make it, fine. If not, we're happy. We'll explain with the recitations what our plan for that is. But yeah, for right now, we're shooting on the lectures to be 3 o'clock Monday and Tuesdays. And then I think Wednesday, Friday recitations, maybe 1 o'clock Eastern time. And then I think Stephen wants to do the guided study group sessions at 4 o'clock Thursdays. So yeah, that's what we're planning for now.
Alrighty.
Any other quick questions? Yeah, let's see if we could take a look at Canvas. And I should join this meeting on my iPad as well. 814. 803. All right, so yeah, looks like everybody should be able to see this Canvas page. I'll take us over to the 231 one as well. So yeah, FYI, we're double dipping a lot of these lectures and course materials for both Math 230, which is 4-credit version. Math 231 is the first 2 credits. And then we'll have some more friends join us halfway through with Math 232, which is the second half of 230. And so anyway, yeah, we'll look at this 230 page first, and then we could look at the 231 and explain the little differences. But yeah, if you check it out, we have our syllabus here. Probably not going to go through all of it, but we can look at a few details. Will this work full screen? Yeah, there we go. So anyway, welcome to the class. We're doing multivariable calculus. Here we have the general course format. So like we said before, there'll be 2 lecture sessions, 2 recitation sessions, 1 study group session per week. As far as the videos go, as far as the assignments, we're going to be using WebAssign. I'll take us there in a moment. And a WebAssign homeworks will be due every Sunday at 11:59 p.m. And then we'll do weekly quizzes on Canvas. I think they'll be an hour-long timed. And those will be due, they'll open up on Thursdays, and they're due Monday at 11:59 p.m. And then for 230, there's going to be 2 midterms and a final. For 231, there will be 1 midterm and a final. And so we'll take a look at Examity in a second. I don't think it's fully active yet, but the exams are going to be proctored online through, I guess, your webcam. Essentially, one of the requirements for this course is that you have a laptop. It has to be a laptop. It can't be a tablet. It has to have the full operating system. I don't think Chromebooks work either. So it's got to be an honest to goodness Windows or Mac or Linux machine. I don't know. Maybe Linux doesn't even work. I don't know. We'll have to see. But anyway, Examity is going to be the service that you schedule the exams for. There'll be a 5-day window for that. So like we said, people are all over the world. There's all kinds of different time zones going on and work schedules and all that stuff. So you always, I guess you have a 6-day window for the homework assignments. You have a 5-day window for the quizzes, and a 5-day window for the exams as well. So take that anytime you want, anywhere in the world, as long as you have a laptop and a webcam. Okay, and then
we got a question in the chat room, FYI, which is it okay to use a desktop if it doesn't have a camera?
No, so you are going to have to get a hold of a webcam. Let's see here. I posted, let's go to the Examity student guide. And that's not doing what I want it to do. Let's preview it here. Yeah, so this Examity student guide will walk you through the requirements. You should click on, I don't know if it's fully implemented yet, but if you go to the Examity tab over here on Canvas and start getting your account set up, you have to go through a few things, like you have to show them your ID. They'll do a technology check to confirm that you have a webcam, you have an appropriate operating system, your internet speed is sufficient. So you should go through and do that technology check on Examity, on whatever internet connection, whatever computer you're going to take the exams on. And so, yeah, I'm sure a desktop computer will work, but you're probably going to need to get a hold of a webcam of some sort. So getting started, select your time zone, ID card, all that fun stuff, and then I have some biometric keystroke signature that will confirm it's you. And so yeah, this is where it talks about once your profile is complete, you're encouraged to run a requirements check. And so yeah, that is something that you'll have to look into and hopefully get resolved.
Another question in the chat. What would the recitation be about? Is the attendance required, and is it going to be recorded? So the recitation, pardon me, the recitation is mostly going to be problem solving. So we're going to look at various problems from past exams from the semester in the past, a couple of quiz problems perhaps, a couple of homework problems, or other textbook problems. It's mostly going to be a problem solving session.
Yep.
We can also use that opportunity to answer specific questions that students have on either general course material or material on the homework, etc. Attendance isn't required, nor is attendance required for the lectures. They are going to be recorded, but the same advantages and disadvantages apply to not showing up, which is it is a problem-solving session, and with that in mind, you may want to ask questions in real time during that, and you will not be able to do that if you're not there in that room at that point in time.
And so, what do I have here? To make sure I can get this set up all correctly, but so we're going to be using a Piazza discussion board for this instead of the Canvas discussion board, because it's going to allow us to merge the 230, 231, 232, so you guys can all talk together. On Canvas, we couldn't do that, but we set up this Piazza discussion board, which I guess Penn State pays for all of you guys to have an account with that. And so if you click, I think for 230, you can click on the side here. For 231, there'll be a link on the page in general, and that'll take you to our discussion board for this. So for example, I thought I created something for recitation, but I can't see it here. But if I want to do a new post, actually it'll probably show up now. So yeah, let's say I can't make recitation because I'm halfway around the world and it's going to be at 2 in the morning, or let's say I'm at my internship or whatever, and I want to request something for recitation. So I selected this folder. I guess folder is kind of like a topic type sorting mechanism on this thing. And so let's say, I have a question, homework 1, problem 11, and okay, I'm stuck. Let's see if this works. Come on, computer. Okay, I'm stuck. I can't make recitation, but could you please go over this? And then, you hit post, post my note. And then Dom and I will keep an eye on this before we get ready for recitation on Wednesday or Friday. We'll check out Piazza to see if there's anything here. And so, yeah, that's the way you can ask questions in recitation without actually having to tune in live. And same thing goes. If the response we go over on the video still doesn't clear it up 100%, you can reply on here, say, look, I'm still confused. Maybe we can respond on here too. But yeah, we want the Piazza to be a great resource for us to be able to interact with all of you, for you to interact with each other. I sort of posted this welcome message here that said that you guys can feel free to, if someone posts a question and you think you know the answer, you can feel free to answer. We'll keep an eye on it to make sure that it's definitely cleared up and you have the right idea. But yeah, we want this discussion board to serve as a way for you guys to interact with each other and interact with us, even if you're not doing it live in these sessions. Yeah, we'll get to that question in a minute. Let's just, yeah, so Piazza will be how we interact. Let's go back to the syllabus a little bit. And yeah, I'll address this question when we're taking a look at this syllabus. Yeah, so anyway, course materials, we're using Stewart's Calculus 8th edition. We're going to be using WebAssign for it, so you either need this code or I believe Cengage, the publisher, has a subscription service that's $100 per semester or year or something like that. I have a link in this syllabus here to the Cengage website, which will show you all the options for this. But anyway, yeah, this is our book that we're using. There's a smaller multivariable only version that's chapters 12 through 16. So yeah, 231 will cover 12 through 14. 230 will cover 12 through 16. And so that's the situation there with that. Let me see, was that the question? So skipping sections in chapters 12 through 14, no, we're going to do 12.1 through 12.6, 13.1 through 13.4, 14.1 through 14.8. About the textbook, I have a PDF of the entire 8th edition. Is that illegal to share? I don't want to get in trouble. I don't think it's legal. I'm not going to get you in trouble, but I don't think I should allow that to be shared on our platform. And also, though, it won't give you the WebAssign code. So I think because we're using WebAssign, everyone is going to need to have an actual license for it.
One addendum that that we might want to make about the about skipping sections through chapters 12 through 14. No sections will be skipped. However, section 13.4 has a fairly extensive treatment of Kepler's laws of planetary motion and projectile motion. We're not going to be looking at either of those. That's
true. I forgot about that. And I think for 230, we will skip one of the sections in chapter 15. But for the most part, 231 is all of 12 through 14. 230 is all of 12 through 16. And yeah, I mean, we all used to use Napster back in the day, but I don't think we should. I don't think I should post an illegal copy on Canvas.
We like our jobs.
Yeah. Anyway, so yeah, we can look at the syllabus. So as far as calculator use goes, not recommended for homework or quizzes. You won't be allowed to do it on the exams. Like I said, there's the online Examity proctoring where you're going to be on webcam, and periodically they're going to make you, look around and show the room, say hi to my office mate back there. And they'll make sure you don't have your calculator out or things like that. So anyway, the problems we ask aren't really good for calculators. The calculator won't really help you all that much. So just keep that in mind on the homework and quizzes. So our grading scale here for 230 is, there's 13 weeks of class for 230. And so there's 5 points per week for homework, 5 points per week for quiz. And so that's a total of 130. And we have our exams and the final exam and things of that nature. Here's a little bit, there's that Examity student guide that's also posted, but here's also some information about what you're going to need for the exams. Like I said, you should try to get your account set up ASAP. I believe our course is going to be imported sometime today, and then the exams will be up there, and you can sign up. I believe our midterms are 100 minutes long. Our final is 150 minutes long, and you could sign up to take that during any time in that 5-day window like we talked about before. So let's take a look at these dates. So for 230 and 231, this is the one time where it coincides. The first midterm for 230 / the only midterm for 231, it will cover the exact same topics. It's going to be from June 1 through 5th. And so in the next day or so, maybe the next day or two, you'll be able to start scheduling that. I think there's a small fee if you do like emergency scheduling within a 24-hour period. But I think it's like $5 or something like that. But no reason for you to need to do that. You know this 5-day window ahead of time. In the next day or two, you'll be able to make that scheduling. And like I said, this schedule right here, June 1st through 5th, that's for both 230 and 231. We'll go through the 231 dates in a moment, but for 230, as you can see here, the second exam is July 6th through 10th, and the final is the 10th through the 14th. And then we did get a question about SDR. So if you have accommodations through Student Disability Resources, it'll be the standard drill where we have to sign the form, and then I guess you get it back to the office in Buki building. I guess this will be done electronically since you're not necessarily in town here. But yeah, once we get that form and we sign it, Examity, no problem. We'll get it set up with the extended time. That's something that's easy enough to do. So yeah, if you have accommodations with SDR, let us know ASAP, and we'll get you rolling on that. Anything else fun here? Yeah, so take a look at the syllabus. I think we've hit most of the big topics. The one thing I want to say, though, is that use this first week to get used to the system. We'll take a look at WebAssign in a moment. But for the most part, since we are giving you at least 5 days to do everything, we're pretty strict on the deadlines. And so I mentioned that a little bit here. We want to be able to post answers to the homework. We want to be able to post answers to the quizzes as a study tool ASAP. And so we are going to be fairly strict, very strict with the due dates for things. So again, stay on top of things. You have at least 5 days to complete any given assignment. And so fair enough. I think that we can not extend deadlines in general. So
just to add on to what Joe is saying, we're using a lot of technology. Obviously, this is an online class, and technology, this is a public service announcement. Technology doesn't always behave the way that we want it to. With that in mind, it is a generally very bad idea to put off doing homework until the very last minute, because if your homework system begins acting a little funny or you haven't set it up yet, then well, we're not really going to be able to do a whole lot to help you at that point for the exact reasons that Joe said. So make sure that you can at least access these things and take care of these things sooner rather than later.
Yeah, it's your responsibility to finish these assignments within the time frame. If you do the Examity during the last 2 hours that it's available and your internet cuts out, that's on you. So it's your responsibility to make sure you complete these assignments within the given time window. So another question I saw, can the WebAssign access code be the one including the ebook? Is there a universal access code for standard classes? I don't really know how this works.
Right?
And for actual questions about WebAssign, you should go with their customer service. They're really good. They know way more than we do about this. As far as I know, there's some kind of code that either comes in the book when you buy it, or you're saying there's the ebook. I think there's no way to get a code without the ebook, if that's what you're asking. And then there's also this subscription service I mentioned, Cengage Unlimited. It's $120 for everything. So yeah, unfortunately, I think you're looking at a minimum of $120 cost for the WebAssign access, but that includes the ebook as well. And as far as getting set up with that, we can take a look. I set it up a little bit differently. Some of your classes might be set up through the Penn State system, but we will be using a class key. So Dom, yeah, this is different from last year. We had enough confusion, so I changed it. So remember, everyone asked us for the class key and they didn't believe us that there wasn't one. Well, okay, this year there is. So anyway, there's one code with the purchase that gets your account set up. And then once you get in, here's the class key for 230. The 231 is on the 231 canvas. I saw some of you were already in. So, who is this?
We'll post recorded videos on Canvas, and there will also be a YouTube channel that we'll create for that exact purpose, for posting YouTube videos of the recordings. You'll get emails about all that stuff.
And I think I'll make it default from now on. It might be an option I have that everyone's mic is off when you guys join. Like I said, feel free to tune in, but just be aware if your mic is on, whoever that was. Yeah, so WebAssign, take a look. Once you get your code and account set up, this is something you guys could probably help each other with too on Piazza. Or like I said, feel free to reach out. You know, you're paying $100 for this, so you're paying for the customer service, so do not be shy with that. $120, sorry. So if you're having trouble getting set up, take advantage of that. Like I said, they're very helpful. But yeah, looks like already 33 people are enrolled and ready to go. And yeah, so first homework, like we said, homeworks in general will be due Sunday nights right before midnight. So homework 1 is up. I saw some of you nerds already working on it a few hours ago. Keep it up. So anyway, that's the WebAssign. And so Examity will look a little different once our course gets imported. Maybe it actually is right now. Let's see here. So what happens when I hit Examity? So course import has not happened yet. So check back in the next couple days to start getting. You could probably get going on your Examity account and run the technology check, but I guess the sign up for the exams won't show up, and our course won't show up for a day or two. Yeah, and then same thing. Here's the Piazza. I guess either one will take you here in your 230. And so yeah, this page will update. So as soon as we're done with this live lecture, YouTube, well, I guess first Zoom takes a little while to process it, then I have to upload it, but yeah, you'll click right here and it'll be the link to the YouTube video of this, and then we'll fill in, you know, tomorrow, second lecture, 3 p.m. and go from there. So if you just stay on top of the Canvas page, you'll find everything you need to know. I guess we could take a quick look at 231. It's pretty much the same, nothing too.
On average, the lectures are going to be about an hour long, same with the recitations. Some lectures may be a little bit longer, depending on how many questions we get and how detailed we end up going into different things. But usually, it'll be around an hour or so.
Today, tomorrow might be a little bit longer, just because we're doing intro stuff. Yeah, I think that's about what it averaged last year. So yeah, 231, same idea. We just weighed things a little bit differently. So 231, it's a 6-week course basically. So we only have 6 homeworks, 6 quizzes for 231. We have the midterm and the final, and then I guess the dates. So like I said before, the midterm, that first exam is the same for all of you guys tuned in right now. And then the final for 231 is 3 weeks after that. And yeah, as far as late drop, I think this is an estimate that the department gave me of when it is, but the only way to see it is actually on LionPath. It's kind of messed up, and I don't think I can actually see it. So I'll remind you guys later as we get closer, but if late drop is something that you think you might have to consider, definitely check on LionPath for when the actual date is. With these dynamic adjustments, I guess we have estimates for it, but the only way to really know is with LionPath, and I was told last year that there's no way for me to see that I don't know. You guys have to find that out. So keep that in mind. Same thing for 230, that the late drop is easier for you to find out. External resources, extra practice. So I think WebAssign comes with a lot of extra things you can do, as far as you could see another version of the problem. You can do things like that. I think here in the syllabus, I put the link to the course websites for during the semester. So yeah, here we go right here. This will take us to the Math 231 website during the semester, and it has old exams here. So our exam format is going to be multiple choice and or multi-part multiple choice. Essentially, all your quizzes and exams will take place within Canvas. So the format will be a little bit different. During the semester, they don't really have multiple choice, but the content's the same. So here's some good resources as we get closer to the exams. You could take a look at the practice tests on here, and I'll post the answers to these as we get closer on Canvas. But external resources, extra practice. Yeah,
we have that for 230 as well, by the way.
Yeah, exactly. Yeah, 230, we have the same webpage kind of thing. There's a lot of other good videos on the internet too. Multivariable calculus is a very visual thing, and so there's wizards out there on YouTube that have made very good visual learning examples, better than we can do. We're not professional artists, although I do want to start practicing that kind of thing. But yeah, homework, old exams, those are pretty good resources.
Something that Joe and I may use a little bit over the semester during our lectures and recitations also is a web applet called GeoGebra. And now this is a very nice little tool that basically allows you to create 2-dimensional and 3-dimensional figures. You can rotate them around, zoom in and out, and do various things. So Joe's getting into that right now.
Yeah, so we'll post about this as, not as we get to things that'll be good for. Actually, it might be good a little bit today, so we'll post it soon. Dom's actually much more knowledgeable about it than I am. But it's not scary at all. So something we'll talk about today is what a cylinder equation looks like. And yeah, the neat thing about GeoGebra is you don't really have to know any fancy syntax. You can do very complicated things. Like some of the stuff Dom's put together is really neat. So if you're willing to do fancy stuff, you can. But for me, I just kind of like to use it to do simple things like, okay, I have to know any special syntax or anything, and now I get this nice little 3D picture. So yeah, we'll be using that. I think Dom will be using it more than I do. But yeah, that's another good resource. I guess I haven't really set up anything yet here, but on Thursday, once the quiz opens, you'll find it here. So go to quizzes. That's like where our quizzes will be on Canvas. But yeah, I guess get your Examity profile set up, get your WebAssign set up, get your Piazza set up. Go take a look, say hi in Piazza. But yeah, any other general questions? I wish it's so weird. I was just about to say, raise your hand if you've never taken an online class before. I think there's a silly little thing, right? There is isn't there a raise hand thing you can do?
I think I saw some button that looked like that. Yeah, my control panel keeps it string though. But wait a minute, let's try it. If I raise my hand, yeah, you get a little raise hand thing under the participant list.
And then I could say, shut up. It says lower all hands. So yeah, as a
host. Can you do that? Oh, there you go. We do not use Examity for quizzes. No, right. Examity we only use for actual exams.
Yeah, I think it's included in your tuition. That I don't know, Examity isn't cheap, and so we don't use it for quizzes, just the exams.
That being said, if you cheat on quizzes, then you are going to be hurting yourself when it comes to time to do the actual exam.
Right.
So don't get comfortable with that.
Anything else? So I think I'm going to see what I could do, Dom. This multiple different Zoom room things is confusing, and apparently someone just joined one of the other ones.
Oh, really? Oh.
Yeah.
Okay.
I don't know. So pay attention on Canvas. We might adjust the Zoom room codes and hopefully try to get it so it's all one type of thing.
Yeah.
But yeah. I guess hopefully all this stuff together is probably pretty new to you. But hopefully you've used WebAssign in some course before. It's not too complicated. And like I said, if you're having trouble, feel free to call their number. That's what they're there for. Yeah. All right. So that's it, Dom. I guess I can get on to the content, or I thought Stephen was going to stop by. Maybe he'll stop by.
Yeah, too bad.
Maybe he's the guy. Maybe he's the one in the other room with all this confusion. So anyway, I guess I'll catch you later, Dom.
Adios, and good luck, everyone. And I will, and some of you will, whoever signs in, will see me on Wednesday, probably.
So I cannot share while the other participant is sharing. So let's stop share. All right, so I will try to get these slides up beforehand. I did not get it today, but yeah, usually I'll try to put these slides up before the lecture starts, and then you'll be able to download them and take a look if you want. But yeah, the plan is let's do chapter 12.1. Let me get my view all set up here. Alrighty, so most of Calc 3 is the ideas of Calc 1 in 3D settings. And so I guess these first couple sections of the book, we got to make sure that we have the same language to talk about things. So a lot of this, 12.1, 12.2, will probably seem pretty boring, but honestly, it's just to make sure that we're all on the same page, but make sure that we have the same correct language we can use to discuss various things. And so, yeah, 12.1 talks about three-dimensional coordinate systems. So we have our X, Y, and Z axes. We have our origin, O. And, we have a point A, B, C, which has X coordinate A, Y coordinate B, Z coordinate C. And as you could see, the X coordinate is how far you go in the X direction. The Y is how far that direction. And then the Z is how far that direction. And so our fancy name for space will be R3. So we got this fancy math R, which I guess if you handwrite it, people usually write it like that. But anyway, R3 is just space, and I guess R is the number line, and R2 is the XY plane. but we'll just abbreviate space as R3. And so, okay, as you guys know, we have the axes. We'll talk a little bit more about this as far as equations and what kind of dimensional objects they represent. But the z-axis has both x and y equal to 0. So it points here are of the form 0, 0, c, for example. And similarly for the y and x axes. And then we have something that we call coordinate planes as well. So the xy plane is the plane formed by the x and the y axes. The xz plane is the plane formed by the x and the z axes, and so on and so forth. And so they're characterized by one equation. So for example, the xy plane is characterized by z equals 0. So any point on the xy plane is going to look something like a, b, 0. So something to keep in mind. And so here's just another picture. Like we said, we have the 3 coordinate planes. And so it's not going to make that big of a difference for your drawings. We will several times throughout the class talk about something called the right-hand rule. It's going to have, I'm sure those of you who've taken physics know what I'm talking about already. But just as an FYI, our coordinate system follows this right-hand rule. So what it means is if you put your right-hand fingers through the x, then the y-axis, and when you're doing that, you go the short way. So you go from x to y, like I just did right here. You don't go all the way around. Basically, you go less, you take 90 degrees as opposed to 270 degrees, or whatever. We're adults, pi over 2, as opposed to 3 pi over 2. Adults use radians. But anyway, if you do your right-hand fingers through x, then y, then your right-hand thumb is pointing up. And so, I guess I don't have it here. You'll see us make various drawings throughout this semester, and you guys, obviously, we're not going to grade you on your drawings since it's a multiple choice, but I think being able to draw and help that develop your visual sense is a really powerful idea. And so depending on what you're trying to draw, you might want to draw things from different perspectives. So this perspective of x, y, and z, that's common. Sometimes you might have the y-axis go directly along the page or the iPad or whatever you're talking about, and then the z-axis is, I guess, also along, whereas, okay, in that case, x is going to have to be coming out of the iPad. Or maybe I want to have the x-axis be along, and I want to have the y-axis, well, I guess the z-axis, let's also do along. But in that case, the y-axis would have to be going into the page. So if you just kind of think about it with your hands, right? Just label your pointer finger X, your middle finger Y, your thumb Z. You can take a look at those axes from any angle. And you just have to keep that same handedness to the coordinate system. So for example, something like this, if like X is out, or let's say, sorry, if Y is out and X is out like this and Z is along, that's actually not following the right-hand rule. That's an evil mirror universe where everyone has goatees. It's a mirror universe. It's not what we have. Like I said, this isn't going to affect your answers most of the time, but just something to keep in mind when you're drawing your axes. Make sure they follow the right-hand rule. Otherwise, you might get a little confused in certain situations. Okay, and so I guess the next idea, the next little vocab word is this idea of projections into coordinate planes. So for example, if I have this point ABC, the point AB0 is the point directly below it in the XY plane. And that's what we call the projection of ABC into the XY plane. And so I guess this is a typo. This should be AB0 right there. And so you could project into the XY plane. You could project into the YZ plane. So for example, the point 0BC would be the point directly behind this point in the YZ plane, or I could project into the XZ plane. I get the point A, 0, C. And so, yeah, there's various times where we might want to do something like that. Essentially, you could think about projection as just being like the shadow of this point into the various directions. And that wasn't the best drawing here. There we go. A little better. All right. So that's, if you read the book, that's pretty much, it does a few more other things. But what I really want to emphasize today, and it's something that's going to be very valuable throughout the entire rest of this class, is this idea of dimensionality and what kinds of equations represent different kinds of objects and things like that. Math 230, by the end, it's very, very challenging because we're synthesizing and we're putting together all kinds of different topics from throughout the semester. And you're going to need to understand, am I talking about a curve? Am I talking about a surface? Am I talking about a solid region? And just sort of having a solid foundation on what ways we describe these various kinds of things is going to be extremely important. So let's try and drill this into our heads on day one. So something that you guys know already, hopefully, is how to draw different curves in the XY plane. So R2, that's the XY plane, an equation involving X and Y typically represents a curve. So by typically, I'm sort of saying it's not a stupid example. For example, x squared plus y squared equals -3. That actually represents nothing. Because, okay, we don't do imaginary numbers in this course, so there's no such thing as I, the square root of -1. So anything squared in this course has to be non-negative. So there's no way on earth that x squared plus y squared could ever add up to be -3. So yeah, there are some equations that aren't anything. There's other equations, for example, x squared plus y squared equals 0. That actually represents the point 0, 0. Right? The only way x squared plus y squared could add up to be 0 is if they're both 0. Because remember, we're not doing imaginary numbers. There's no, anything squared has to be at least 0. So the only possible way x squared plus y squared could be 0 is if they're both 0 on their own. But okay, let's assume we're not in one of those cases. Typically, an equation is going to represent a curve. And so what is a curve? We could do a full formal mathematical definition, but that's not super important for us. I'd say let's just get an intuitive idea. So a curve is something that's one-dimensional. So it can live in 2 dimensions, but the curve itself is one-dimensional. And I know we're talking about the XY plane right now, but let's, yeah, we could, throughout this course, we're going to talk about curves in space. So look, I have my little charging cable here. Obviously, this thing isn't one-dimensional. It actually is 3-dimensional. But pretend it was so thin that I was modeling it as a one-dimensional thing. If, you know, this thickness that it had, this cross-sectional area was 0. If it was just a one-dimensional curve, it lives in 3D, but the thing itself is one-dimensional. So when you have in R2 an XY equation, that typically gives you a curve. So this is what hopefully you're familiar with. Y equals x squared. As soon as I say that, you guys should be thinking, oh yeah, that's a parabola. X squared plus y squared equals 4. Oh yeah, that's a circle of radius 2, right? Y equals 3x plus 2. That's the equation of a line with slope 3 and y-intercept 2. So these are 3 examples of equations involving x and y. And visually, they are, if you draw the points that satisfy them, you end up getting a curve. And so yeah, curve is something that has length, but not area or volume. So this curve, these curves live in R2, but they themselves are one-dimensional objects, right? What's the area of this curve? Well, it doesn't have it. Okay, I know in Calc 1 you talk about area under curves, but area of the curve doesn't really have it. It's 0. What's the volume of a curve? 0. What's the length of a curve? That makes sense. So a curve is something that you would answer the question, how big is it? You would answer it with length or units of length, whatever. And so intuitively, this idea that you have a one-dimensional object, you could think of initially with x and y, that's two variables. And by enforcing one equation, you've taken away one of those degrees of freedom. So x and y, whatever, that's the whole xy plane. But if I say, you know what, y can't be anything, y has to be x squared, I've sort of made it so that knowing x gives me y. And so now I started with 2 degrees of freedom with x and y, but if they have to satisfy y equals x squared, I'm down to 1 degree of freedom. So anyway, that's that. So pretty much what we're going to be doing throughout this course is just kind of scaling up ideas that we're already comfortable with from Calc 1, or even at this stage, we're not going to be doing calculus for quite a while. I guess this is kind of like pre-calc scaled up to multiple dimensions. Is just, yeah, taking the situations we're familiar with and scaling them up to more dimensions, deciding what's the same, what's different. Often things are a lot more complicated, but other times it's simply same concept, slightly more complicated context. But anyway, if we think about space, R3, an equation involving x, y, and z typically represents a surface. So, okay, what's a surface? A surface is something that's two-dimensional. So, I don't know, whereas my charging cable was sort of what you want to think about for a curve in space, a surface could be this sheet of paper right here, right? Obviously, it exists in the real physical world, so the thickness is non-zero, right? There is some thickness to this piece of paper, but whatever, it's pretty thin. If we imagine that the thickness is 0, then I'm left with a two-dimensional object that lives in 3D. And so surface, you want to think of something that's measured by area, not by length, not by volume. You know, how long is this piece of paper? It doesn't really make sense, right? You have length, width, but like I could draw a curve of infinite length that lives on the piece of paper. So the proper way to measure a two-dimensional object is with area. And so that's what we'll call a two-dimensional object for the purposes of this course. And so you could think about it as far as the degrees of freedom argument as well, that starting with x, y, z, that's sort of, you got 3 degrees of freedom, but then you enforce one equation, then you're down to 2. So 2 degrees of freedom, two-dimensional object, that's what we'll call a surface. So yeah, let's draw the points that satisfy z equals 3. So we have our x, y, and z axes. We already said a few minutes ago that z equals 0 is the equation of the xy plane. Z equals 3. Yeah, which points have z equaled 3? Well, it's this horizontal plane. It goes on forever, right? I'm not making any restrictions on x or y, so yeah, it goes on forever. But z equals 3 is the equation of a horizontal plane. And as you can see, it's a two-dimensional thing. It's got area, doesn't have volume, but that's the idea. And so I guess the first thing I want to point out is that context is important. And so sometimes in this class, we're going to be doing curves in the XY plane. Sometimes we're going to be doing surfaces in space. Sometimes we're going to be doing curves in space. And so if you're not careful about the kinds of equations that do these different things, you're going to just be you're going to be very confused and have a real hard time solving the problems. And so I guess what I'm trying to get at in this slide is that, okay, y equals x plus 1. What is that? If I asked you that, and that's all I said, you should say, I can't answer that. You're not telling me the context. Because if I'm in the xy plane, we of course know that we're getting a line, right? Y equals x plus 1, that's slope 1, intercept 1, whatever, it's a line. But what points in R3 satisfy y equals x plus 1? So it turns out it's a plane. It's a little bit more complicated of a plane compared to our previous example. But let's try and understand this. So I guess next week on probably Tuesday's lecture, we'll talk about, well, on Monday we'll talk about more kinds of planes, and on Tuesday we'll talk about this idea of cross-sections and slicing up an object or something like that. So yeah, what points in R3 satisfy y equals x plus 1? Do I want to draw it from this perspective? I don't think I do. Yeah, so something you'll find out about me is that I am not a good artist. I failed out of art school, or I had the good sense to not even try. But hopefully, with a little practice, you can get to the point where, yeah, okay, it's not the prettiest thing in the world, but it gets the point across. Let me try. There we go. That's a little bit better. So what I'm trying to do here is think about how this line I drew up here, which, okay, do I have a good way of, yeah. I want to figure out what I drew up here. Yeah, I don't like that. I'll just use arrows. How that situates in space. So I have my drawing in the XY plane. I'm going to see how this goes down here. Yeah, so anyway, good question. I'll post these blank slides before, I'll try to, and then I definitely will post these written out slides afterwards. I think the way Dom has his technology set up, he won't be able to post what he writes, so you'll have to take more notes as he does it. But because of that, Dom's slides are going to have many more words on them. So my slides will have a lot of places where I can draw in, and I'll post that. But for his, they'll be a little bit different. But yeah, definitely I'll post the PDFs afterwards. Cool. Yeah, so anyway, what I did here, I tried to figure out how this picture situates, because remember, the XY plane lives in space. So what would that picture look like in the XY plane? It would just be that line. And so then at this stage, look at this equation. It doesn't have any z in the equation. So guess what? Like right now, this is the part of it where z is 0, this line here in the XY plane. But I could draw the same line when z is 1. I could draw the same line directly above it, same line directly below it. And yeah, we'll talk more about planes later on, but essentially it's the plane where if you stood up here on the z-axis and looked down, or whatever, I guess the plane does go on forever upwards, but if you adjusted your perspective so that the XY plane you were looking at down, you would see this up here. So anyway, I guess I could call this a vertical plane. And so yeah, put an X and Y axis on your desk, and put this piece of paper here to make it look like y equals x plus 1 when you're looking at it from this perspective, and then, yeah, you get a plane. Same little exercise here, difference in context, that x squared plus y squared equals 1. If I said, what is that? You're probably thinking, oh yeah, that's the unit circle. That in R2, x squared plus y squared equals 1 gives you a unit circle. And so now, okay, what points in R3 are described by that same equation? Essentially, it's the same kind of thing we did on the last slide, and we'll talk about this more on Tuesday. But essentially, I know some of you are maybe thinking sphere. We'll talk about spheres in a moment. But we actually get a cylinder. So same idea. I can draw this in the XY plane, but then z could be whatever it wants. That equation doesn't place any restrictions at all on z. So essentially, you get this in the same way that the plane on the previous slide was a bunch of lines stacked up. This cylinder we get is a bunch of circles stacked up. And whatever, I'll call this a circular cylinder. We'll talk, in fact, there are other kinds of cylinders. But it's all about context. So quick question. Yeah, recitations honestly are the same kind of thing as lectures. It's just they're slightly more based on problems. And it gives us basically, the lecture is sort of more of the background material. The recitations is more examples, but it also gives each of us the time to express our own point of view, or our own way that we like talking about certain things. But as far as required, attendance, posted, whatever, recitations, lectures, same thing. So everything we do on here is going to be everything we do here is going to be posted on YouTube. And yeah, and attendance, we can't, if we could do attendance, that'd be tricky because like I said, there's 140 of you all over the world with 140 work schedules, sleep schedules, all kinds of stuff. So properly setting up XYZ axis. So honestly, there's no best way. I mean, for me, it's as long as you're following the right-hand rule, you're correct. But after that, it's really just an issue of if it's convenient for you to draw it. So for this previous one, I wasn't as, I mean, obviously this picture is not great, but I wasn't as confident in my ability to illustrate what was going on like this, that if I tried to think about how that line would look with this perspective, okay, that could have been fine too. I don't know. I guess the answer to your question, how do you know? Well, I guess you really don't. You do your best. And big thing is to just make sure you're following the right-hand rule. So you go through X, then Y, and Z. So and you always go in the 90-degree direction. So if I do my right-hand fingers through X, then Y, Z is up. If I go through X, then Y, Z is up. But if I go through X, then Y, the reason that this one fails the vertical line test, or not the vertical line, what am I talking about? We will talk about that later. But this one fails the right-hand rule because if you go through X, then Y in 90-degree angle, then your right-hand thumb is down. And this is bizarre. Oh God, I'm looking in a mirror at this webcam. It's driving me crazy, but yeah, that essentially that here breaks the right-hand rule. But at the end of the day, like I said, it's not a huge deal. I always draw my Z-axis up, and then I rotate around my X and Y axes as appropriate. And good God, well, it probably looks correct for you that this is my right hand. So in R3, a line would essentially be an infinite wall. A line would just be a line still. I'd say a wall is more like a plane. Videos depends on my upload speed at my apartment is a little bit slower, and Zoom takes a little while to do it, but within an hour or two is when they'll be on YouTube. Yeah, so we haven't talked about a line in R3, but a line in R3 would just be, you know, just a line. Straighten out this cable and pretend it's one-dimensional. And so, yeah, we can't just look at an equation anymore. We have to specify where we're thinking. So y equals x plus 1, it's a line in R2, but it's a plane in R3. X squared plus y squared equals 1 is a circle in R2, but it's a circular cylinder in R3. And so we'll talk more about the fact that, like, figuring this out, you're looking at the fact that z is missing from the equation. So you're really just stacking up at the same thing. But yeah. Oh, okay. Well, and then hopefully this will clear that up too. That curve in R3, we haven't really talked about yet. I guess we kind of just did a second ago that, like, you could think about your really thin cable or a piece of string or wire as being a one-dimensional object that lives in R3. And so we'll spend a whole chapter talking about a different way of describing curves in R3 using something called parametric equations, which hopefully you remember a little bit from 141, but probably not. We'll start from scratch. But one way we could talk about a curve in R3 is as the points that that two surfaces have in common. And so we kind of already said this before, that the x-axis, if you think about points on the x-axis, it's of the form, you know, A, 0, 0, right? The x-axis consists of points that look like that. So you could think of the x-axis as being defined as the intersection, it's the points that the xy plane have in common with the xz plane. That I have my xy plane here, I have my xz plane here, and the points that they have in common are this line. So let's draw that. So your question, if z was defined, it could be a line in R3. I'd say you actually have to fix, for this kind of thing, you really need two equations to narrow yourself down to 1 degree of freedom. Because remember, in space, you have x, you have y, you have z. You have to make two demands in order to reduce your degrees of freedom to 1. So by saying I only care about points where x is 0, I only care about points where, where z is 0, where y is 0, then I get this intersection, this red curve that I've drawn here, the x-axis. We could do another example. What if x squared plus y squared equals 1 and z equals 5? So x squared plus y squared equals 1, that's a cylinder. And I want points that are on that cylinder and on the plane z equals 5. If I ask myself, what do those 2 points have in common? Well, it's a circle, right? It's this, I don't know, I'll make it red. Red circle of points that live in the plane and live on the cylinder. And so this goes back to, if you scroll back up to some of our previous examples, I put "and" in italics. So one equation in R3 gives you a surface. Oftentimes, not all two surfaces intersect. For example, these two planes that I draw here, they don't intersect. But if you have a surface, if you have two surfaces that actually do have points in common, that tends to give you a curve. So that's why I had an equation for the previous situation, and I'm putting two equations for this kind of thing. So that's one way to talk about curves, but we will have another way and talk much more about curves later. This is just sort of a brief introduction. Okay, so then the next thing to get us on the same page is this idea of a distance formula. So I could use this notation. I guess I didn't mention it, but on our very first slide today, we had the notation for coordinates of a point. So if I have a point P1, whose coordinates are x1, y1, z1, that's the notation I'll use. So P1 is the name of the point, and then the point coordinates are here. Pretty clear. So if I have 2 points, then I could use the Pythagorean theorem 2 times, it turns out. There's a nice picture in the textbook if you want to see exactly where this is coming from. But basically, you subtract the corresponding points and square them and add them up and take the square root. So that's a distance between 2 points. And so now you might wonder, okay, we talked about cylinder a couple minutes ago. What is a sphere going to look like? So by definition, a sphere is the points a fixed distance away from the center. So let's say we have a sphere centered at HKL, and we want to talk about the points R away from it. And so we could translate this definition of a sphere into an equation like this. So yeah, the XYZ is on the sphere, provided that XYZ to HKL is R, the distance between those is R. So if we write out the distance formula for distance from XYZ to HKL, and then square it, we end up getting that this is the equation of a sphere. And so in R2, hopefully you remember at some point you saw the equation of a circle. But, uh-oh, what is going on? Okay, sorry, my computer got goofed up. Yeah, so anyway, that's the equation of a circle that you might have seen in previous courses, hopefully. And so again, we just have this new term, z minus L squared. Okay, and so we talked a little bit about curves, a little bit about surfaces. What's the third kind of thing? Well, the third kind of thing would be an actual three-dimensional object that lives in R3. And so we'll call that a solid region. And so typically, for a solid region, you're going to use inequalities for everything to describe something that has volume. So for example, what region is represented by x minus 1 squared plus y squared plus z squared less than or equal to 4? Well, I could rewrite this as the square root of x minus 1 squared plus y, well, I'll write it as y minus 0 squared plus z minus 0 squared less than or equal to 2. I could sneak in my zeros here, of course, right? And then I could say that this is really saying the distance from x, y, z to 1, 0, 0 is less than or equal to 2. So basically, it's points on or inside the sphere of radius 2 centered at 1, 0, 0. So I have my point 1, 0, 0, the center. And for this, you don't have to draw your axes at all. But if you want to, I guess your x-axis would be like that, your y and your z. And so yeah, everything on or inside this sphere. So I would call this either a solid sphere or a ball. Ball is the mathematical terminology for this, whatever, funnily enough. But think about the surface of the Earth as a sphere, and then the Earth itself as a ball, because the Earth has stuff inside of it, right? It's not just the surface. I think I point that out on a later slide. But anyway, we can have multiple inequalities. So what region consists of points satisfying x is between 0 and 2, y is between 0 and 2, z is between 0 and 2? Well, I would call this a solid box. I guess in this case, more specifically, it would be a cube. But yeah, think about it. What points have x between 0 and 2 and y between 0 and 2 and z between 0 and 2? I guess, yeah, box is going to be our synonym for that the book uses, and we could pick up on it, a rectangular prism. Yeah, cube is like a square, rectangular prism like a rectangle. And so yeah, just I bet you never thought there was much of a difference between a circle and a disk, but in the spirit of keeping the dimensionality of things in mind, let's use different words to describe it. So I'm not going to take, well, yeah, you guys should know this, which one is which. It'll help you not get confused. So the circle, the points exactly 1 from the origin, looks like that, whereas the points at most 1 away has the points on and inside. And so we'll call that a disk. A circle is a curve, and a disk, oh yeah, I guess I have that written here. The circle is a curve, a disk is a two-dimensional region. Whereas a sphere is the points exactly 1 away. So nothing inside. It's just the surface of the Earth, the Earth's crust, whatever. Whereas everything on and inside the sphere, that's what we're going to call a ball. So fun little SAT analogy time. And so, yeah, big thing in this course is keeping the dimensionality of things in mind and having the proper description as far as equations, inequalities, things like that. And so I think that's about it for today. Take a look at the WebAssign. Make sure you get your account all set up. Maybe try these problems. It's all grouped together as one assignment, but I think you're able to tell which problems come from which section of the textbook. And yeah, let us know on Piazza if Dom should go over anything in particular from that on Wednesday, but otherwise my plan is to talk about sections. Yeah, tomorrow will be a long lecture, 12.2 through 12.4. Since we did a lot of intro stuff today. But yeah, I will post the blank slides. I will post the annotated slides. I will post this video to YouTube. But before we sign out, any quick questions? Or long ones, whatever. People could fast forward or just not even watch it. No rush. Getting a certain number of attempts. Yeah, I think it's 6, could be 5. 5? Okay, thanks. Yeah, I just kept it on whatever the default was. And you get full credit no matter how many attempts it takes you. So. Anything else? And I'll let you know when you can sign up for the exam slots on Examity. Again, that should be within the next couple days. But you could probably start getting your account set up with uploading your photo ID, doing the technology check. Well, I guess I will stop the recording then. Let's see here. Yeah, but nothing else. I guess I'll see you here tomorrow. Like I said, tomorrow will be a little bit longer since we got to catch up for the intro material today. But nice meeting you, and welcome to the class. And hope everybody's having a good summer so far, and I'll see you tomorrow.